Hello and welcome to Module 3, Concept Generation, Functional Analysis, System Architecture, and Design. In this case here, we will be talking about detailed design. Recall from our earlier discussions on the design and configuration item level. This includes the detailed design, synthesis, evaluation, specifications, and design review. While the process appears to be linear and is intended to be as such, it also incorporates iterative feedback loops all throughout. Up until now, we have discussed the conceptual and preliminary design aspects of the system development process. Now we are moving on to the detailed design and development. This phase will conclude with the product baseline and is the lead-in to the actual system construction elements. In detailed design and development, this will begin with the configuration and allocated baseline preliminary design. By the time you get to this point, you should have a pretty good configuration allocated baseline from the earlier system design phases. That means your system definition, including architecture and requirements, should be very well known. If that is not the case, then you are not ready to move on to detailed design. Realization includes describing subsystems, units, assemblies, lower-level components, software, people, and elements of logistic support that make up the system. It also includes preparing specifications and design data for all system components, procuring commercial off-the-shelf items or doing detailed design for unique items, developing an engineering model, a service test model, or prototype model of the system and its components for test and evaluation, integrating system components and testing the integration to verify compliance with the specified requirements, and redesigning, re-engineering, and retesting the system or an element thereof as required. Recall again the V process model from our earlier discussions. The detailed design must be taken down to the component level. In order to bring it back up again, these need to be verified, first as components, then again as subsystems. This is another critical juncture of the system development process, and is very important to be wary of throwing things over the wall. This means all subsystems, components, and stakeholders must be considered. Again, that doesn't mean that you don't have to compromise in light of trade-offs, but those trade-off analysis should be completed using their requirements as considerations. Some common terminology to understand include concurrent engineering, simultaneous engineering, and integrated product development. All of these terms are common terms that can effectively be used interchangeably. They refer to the systematic approach of creating system design that simultaneously considers all phases of the life cycle. This scope includes conception through disposal and encompasses production, distribution, maintenance, and phase-out elements. Regardless of which term you're using, they all include very similar concepts, including design for manufacturability, design for affordability, design for disposability, design for reliability, and design for supportability or serviceability. These are just a few of the many design considerations. The concurrent approach is a natural evolution of the detailed design. Remember that the original waterfall method, that included identifying all the requirements up front and holding them static until the eventual completion of the project. This was eventually found to be short-sighted as it didn't consider the need to be iterative nature of system design. Concurrent engineering approaches that took this one step farther. Rather than doing system phases in a linear fashion, each with their own iterative feedback loops, it considers all respective subsystems in parallel as well. Keep in mind that the more that is done in parallel and the more iterative the process, the more complicated system development process can get. In addition, it also places greater criticality on the shoulders in the early phases of the system development process. This is just further detail explaining why it is very important to have good system engineering concepts integrated upfront in the system development lifecycle